Hello and welcome to another lesson that is part of the TI-30XB student course. In this lesson, we will use the TI-30XB to help solve a trigonometry problem. Now the TI-30XB can help us perform the following calculations. It can help us to find the lengths of unknown sides and the magnitudes of unknown angles in right-angled triangles. And it can also help us solve right-angled triangles, including those that involve direction and angles of elevation and depression. In general, the following steps can be used to solve a problem involving trigonometry. Step 1, if a diagram is not given, use the information in the question to draw a diagram. Step 2, label all the given information, side lengths and angles, and all other required information. Step 3, determine what trig ratio should be used, and the memory device SOH-CAH-TOA can assist here. Step 4 is write an equation including the unknown side length or angle and solve the equation. And step 5 is express your answer to the required number of decimal places. So let's look at these steps in action by looking at this example. This example is dealing with an angle of depression. So let's first of all establish the example and then we'll look at what the angle of depression is. The angle of depression from a drone flying 100 meters above the water to a buoy at sea is 23 degrees 18 minutes. We're asked to find the horizontal distance from the drone to the buoy and give your answer correct to 1 decimal place. Now, the angle of depression is formed when an observer looks down at an object. Specifically, the angle of depression is the angle formed between the horizontal line, which is straight to the observer's eye, and the line of sight when an observer looks down at an object. And you can see the angle of depression in the diagram that I've drawn there. You can also note that if that angle of depression is 23 degrees 18 minutes, then the angle inside the triangle is 23 degrees 18 minutes. Notice that we're required to find x, and also note that we've been told that the drone is 100 meters above the water. So we've drawn our diagram as shown. Now we label the diagram, and we've done that nicely. And we now look at what trig ratio we should be using. And we're going to use the TOA bit, that the required trig ratio is tan. Tan is the opposite side length divided by the adjacent side length. The opposite side length is 100 and the adjacent side length is x. So we now write the equation that tan 23 degrees 18 minutes is equal to 100 over x, and therefore x is equal to 100 over tan 23 degrees 18 minutes. It's now time to compute this value for x using our calculator. So we're going to enter 100, then we're going to press the fraction key. Now we press the tan key and we enter 23, and that represents the number of degrees. We now press second PRB, PRB being short for probability, and that takes us to our angle menu. And you can see there that the DMS stands for degrees, minutes, seconds, and number 1, we see the degrees symbol. So if we now press enter or 1, that will paste the degree symbol next to 23. Now we enter 18. We press second PRB to again access our angle commands. And we now want to press number 2, which pastes the minute symbol onto our screen. So we now have tan 23 degrees 18 minutes. We now press the closing bracket key to match the opening bracket that comes with tan, and then press enter. And we get an answer of 232.197, etc. meters. And that's the horizontal distance from the drone to the buoy. However, note back at the question that we're asked to give our answer correct to 1 decimal place. So we could examine that answer and say, okay, correct to 1 decimal place, it's 232.2 and the unit is meters. What we could also do is we could press mode. We could then arrow down to float, then scroll across to highlight 1, and that corresponds to giving answers correct to 1 decimal place. Press enter, then press second mode to quit out of there, and then simply press enter. The calculator redoes the calculation and it gives our answer correct to 1 decimal place, 232.2 meters. Okay, that's it for this lesson. Thanks for watching and bye for now.